Hello, everyone. My name is Ainur Montayeva. I am a PhD student at the Eurasian National University. The topic of my presentation is analysis on the behavior of soils to the anti-frost additives. So I am from Kazakhstan and I live in Nur-Sultan city. My country borders with 5 countries such as Russia, China, Kyrgyzstan, Uzbekistan, and Turkmenistan. As I said before, I live in Nur-Sultan city, which is capital of Kazakhstan. So in the capital of Kazakhstan, we have a very beautiful winter. It's very nice, but very long and very cold. I can say that it's very severe. So the photos that you see are real. So the freezing depth gets in my city 2 and 2.5 meters in winter months. And the main problem of a pile foundation in winter is frozen ground. And the frozen depths, as I said before, in central and in northern Kazakhstan gets 2.5 meters below the ground. The winter usually lasts for 4 and 5 months. It starts from November till April. So we usually use prefabricated concrete piles. So in winter, there is a high risk of concrete piles, a high risk of destruction, pile destruction. The concrete pile develop complete horizontal cracks, and sometimes the head of piles also can be broken. The cracks in piles leads to the penetration of water into the concrete structure. And also driving prefabricated concrete piles needs additional preparatory works because of the frozen ground. Mainly we drill the places of piles, and sometimes the piles can be driven out of its accepted location. Also there is a necessity of special mechanized equipment like a drilling machine, like hammer, which needs additional cost, like for fuel, for labor. So we to solve the problem, we propose the method of using antifreeze reagent that can protect the soil freezing. So antifreeze reagent can serve as a thermal insulation for the soil when temperature drops below freezing in winter months. Also, it can also thaw the soil locally in winter. So while when the soil is very soft and protects from freezing, you can also test the piles for bearing capacity. So there is a possibility of doing bearing capacity in winter. So our antifreeze reagent that we propose is consisted of calcium chloride, sodium chloride, corrosion inhibitor, and a quicklime. So before testing the antifreeze reagent at the construction site, we decided to do a model test at the laboratory before doing the test, we identified the mechanical properties of soil. Also, the purpose of this research is to see the thermal effect of antifreeze reagent on soils in negative temperature. So also to identify the construction of reagent, the soil was tested at the freezing camera under different temperature and concentration. So here you can see the Gibbs diagram for antifreeze reagent. Also, we calculated how much antifreeze reagent we need to prevent the soil freezing. So here the equation to identify the mass of antifreeze reagent. So we had three different boxes to get comparative results, and we also modeled files and printed it in 3D printer. So the first box was filled up with soil without the antifreeze reagent, and kept in the and kept in the freezing camera. And the second box was also filled with soil and was applied, and on the top of the soil we applied antifreeze reagent. And we also put it to the freezing camera. And the third box was filled up with soil but kept at the room temperature. So in the laboratory. So after 2 weeks, we drive the model files into the soil that we put to the freezing camera, and the box that we kept in room temperature. So the first box that we had a antifreeze reagent on its surface was soft because the antifreeze reagent could prevent the freezing. So we could drive the pile in certain heats. And the second box that kept in the room temperature also was soft, and we could heat it in 8 heats. And the third box that had no reagent, antifreeze reagent, was very fully frozen, and we couldn't drive the file, so files just was broken. Here you can see the comparative results between the between two boxes that had an antifreeze reagent and that kept in the room temperature in normal soil. So we also did an experiment at construction site to see the effects of antifreeze reagent, to see whether it so the already frozen soils. The outside temperature was minus 27 degrees Celsius, and we applied antifreeze reagent locally in place of 2 piles. The places where we applied antifreeze reagent was soft, and after the 7 days, the antifreeze reagent soaked the soil for 10 centimeters. After the 2 weeks, we decided to drive one of the piles to drive into the soft soil where we applied antifreeze reagent, and one of the piles was driven into the already drilled place, so holes. So the number of impact on already drilled locations was 198, while the number of hits on solid ground was 200. So the number of hits was the same, almost the same, which demonstrates the efficiency of antifreeze reagent in preventing the soil freezing. We patent the method that we have proposed. So here you can see the conclusions have been identified, and the protecting effect of antifreeze reagent from soil freezing in winter. Implementation of the proposed method leads to the high productivity driving of reinforced concrete piles without the risk of their destruction. There is no need on additional drilling works and more powerful and expensive hammers for driving piles if the soil had been protected from freezing. The given formula of calculating the mass of antifreeze reagent can protect the soil without harming not only the soil but also the structure of concrete pile and the environment. The comparison of two model box tests has been proved the effectiveness of antifreeze reagent, which is the penetration of piles into the ground in winter time. Also, it has been possible to test the piles for static loads test in winter, and it has been verified that the antifreeze reagent can decrease the compressibility of frozen soil. So this is the end of my presentation, and before ending the presentation, I would like to thank Australian Geomechanics Society for providing a scholarship which supports the cost of my accommodation during the conference. Also, I would like to thank Kazakhstan Geological Society for selecting me as a nominee. I would like to invite you to the 17th Asian Regional Conference on Soil Mechanics and Geotechnical Engineering, which will be held next year in Nur-Sultan City between 14th and 18th August. Thank you for your attention.